Next, we are going to take a look at a chart. I gave you a handout. I want you to staple this into your notebook. Protons, neutrons, and electrons. Those are the subatomic particles, and we're going to discuss their electrical charge, their location in the atom, and their relative mass. Relative mass meaning their mass in comparison to the other particles of an atom. And then we'll discuss a few other facts that we need to understand about these subatomic particles. So I want you to copy this into your notebook as we're discussing it. Protons, neutrons, and electrons. There's 3 columns in this chart. And we're going to discuss it by row. So first we're going to discuss the electrical charges. Protons have a positive electrical charge. Neutrons have no electrical charge. And we also may use the term neutral, meaning no charge. And then we have electrons. And electrons have a negative electrical charge. So if you want to remind yourself by putting in a plus sign and then a negative minus sign for those protons and electrons, you can do that. Location. Well, inside the nucleus is where we will find protons. Neutrons are also found in the nucleus. And lastly, the electrons, we can find those orbiting around the nucleus and something that we call the electron cloud. So let's take a look at that real quick. We have an atom here. And in this atom, we have something called a nucleus. And the nucleus is that centermost piece in the atom. Okay? It's very dense, and it is small. Okay? And inside that nucleus, we have our protons, and I'm labeling those with a P. And we have our neutrons, which I am labeling with an N. Those are both inside the nucleus. Our electrons are found on the outside of the nucleus. Okay? And our electron cloud is where it just shows us the area in which electrons are moving. So let's continue to talk about mass. Now, when we talk about the relative mass, again, we're talking about the mass of the subatomic particles in relation to each other. The proton has a mass of about 1 AMU. The neutron also has a mass of about 1 AMU. So they're relatively equal to each other. However, the electron is much, much smaller. It's only a fraction of an AMU, a very small fraction, 1/2000th of an AMU. For example, it takes about 2,000 electrons to equal the mass of 1 proton. And AMU stands for atomic mass unit. Scientists had to come up with a special unit to measure these small particles because grams wasn't even small enough to measure these. Lastly, I'd like you to copy down this part here, some of the special facts. Protons repel each other, kind of like magnets. When you push the 2 north poles of magnets together, they force each other apart. There's a strong force. The same thing happens when we try to put protons together. They repel each other, creating this very strong force that keeps the nucleus intact. If you look at your book, on page 62, there's a sample of an element box. And it has an atomic number, atomic mass, it has an element symbol, and it also has the element's name. When you look at the atomic number of an atom, of an element, it tells you how many protons are in that atom. And the number of protons stays the same. no matter what kind of atom we're talking about, it is consistent. The protons stay the same. Let's talk about neutrons now. Okay? Neutrons, if you take the atomic mass and you minus the atomic number, you will find the number of neutrons in an atom of an element. Something special to know about neutrons is that the number of neutrons changes, and it becomes a neutral atom will become an isotope when the number of neutrons changes. The mass will also change because of that. Lastly, the electrons. The electron cloud represents all the orbitals of electrons. In a neutral atom of the number of electrons will always equal the number of protons in a neutral atom. However, if a neutral atom, gains or loses an electron, it becomes something called an ion.